The Water Lab at the University of Nebraska-Lincoln's College of Engineering is where researchers go with the flow.
Well, we're trying to test a set of devices that can be used to limit the amount of energy in the flow that comes out of these culverts.
Admiral and his students build scale models of actual existing culverts.
When the water first flows through there, it starts to carry away sand from the bed downstream of a real culvert. And so we're watching kind of what happens in the real world. The sand moves, gets carried away, and it builds a scour hole. And unless they have a basin that's already built there, it does scour out.
Admiral tests different ways to cut down the amount of energy in the water flow. The goal is to reduce erosion downstream.
This would represent a sill, something that we put in the flume that would represent a concrete sill that would go across the bottom of the flume. It'll back up the water when I put it in, and that'll dissipate some of the energy in the flow. So if you look, it creates a hydraulic jump upstream of this. That dissipates a lot of the energy coming in. Now the water coming out into the scour basin has a lot less energy, and that of course is going to mean that the scour hole will be a lot less deep and less long. So this is the scour hole that formed after probably about 10 minutes of running the model. And you can see it's probably about a foot deep or so. If we had let this run for 3 hours or so, it probably would have increased another 2 feet.
For their next project, Admiral and his team construct a scale model of a large box culvert in the Florida wetlands.
That box culvert that we're doing for South Florida, they had a failure in that culvert where sand was eroded away from the outside of the culvert, and they had precast sections for the culvert fail. They actually collapsed.
Is there any markings I had on that?
The Florida model is more than 10 feet long, and lasers will measure the water passing through it.
We're going to be using a laser to illuminate some particles, and we'll be able to capture them with an digital camera. And with those images, we'll see how far the particles traveled in an amount of time. And then we'll be able to calculate the velocity distribution, or the velocity from one end to the other on this flume. Some of the work we're doing will help to save some of the infrastructure that's used in stormwater areas in Florida.
Safety is improved, but also the costs that are associated with a failure. If this thing fails only moderately, no one's going to get hurt, but you still have to replace the structure, and that's extremely expensive.
So these researchers will continue testing the water to make our infrastructure safer and more efficient.